Hi everyone. So today I'll talk about spanning tree protocol, which is operated on layer 2. Um, so spanning tree protocol is the protocol that is used to build a loop-free topology, which means that if there are multiple switch and there's host 1, host 2 connected, something like that, and the switches are required to do broadcasting, so it should not go like this forever. So for that spanning tree protocol is used. So in terms of DC core, um, NXOS supports both RSTP, which is rapid spanning tree protocol, and MST, which is multiple spanning tree protocol. So these two. Now, yeah. So STP is used or RSTP is used for ensuring loop-free topology for one VLAN only. It cannot work for multiple VLANs. Now we will talk about the states. So the first state in spanning tree protocol is disabled state, and for disabled state, the port from where the BPDUs or any broadcasting message is going to be sent. So for disabled switch, the port is in administratively off position. So right now it's doing nothing. The second is blocking state. So in this one, switch port is enabled, but the port is not forwarding any traffic. So this will be helpful when we want to stop from broadcasting either in a loop. So it will stop here. So it will not be a loop. Now, in this blocking state also, the switch cannot modify the MAC address as well as but it can receive definitely BPDUs, which is also called bridge protocol data units, from other switches, but it will not be able to forward it. Now the third is listening. So in listening, port transitioned switch port transitioned from blocking state and can now send and receive BPDUs. BPDUs is just packet where all the information is there about these switches and every other identifier. So receive BPDUs, but it will not cannot forward any other network traffic. So it can just do the BPDUs part. Now the fourth stage is learning stage. So for learning stage, ports can switch port can modify the MAC address table. So that is what it meant here also. Um, yeah, for blocking it cannot modify, so MAC address table cannot be modified. And for learning stage, the like we can modify the MAC address table, and but it does not forward any other traffic beside PBDUs. So can modify MAC address table. Now, fifth is forwarding state. So in this state, port can forward all network traffics and can also update MAC address table. And the last is the broken state, which is generally used for like configurational or operational problem in the port, which is very rare and is mostly not used. Now we can talk about three different types of ports. First is designated. Designated port. This port actually receives and forwards the frames to other switches. So like it provides the connectivity to downstream devices and switches. Okay. Then second is root port. So root port is like port where a network port that connects to root switches. So any port that is connected to the root switch or an upstream switch is a root port. Designated is to provide the downstream one. And the third is blocking port. So blocking port is a network port that is not forwarding any traffic, forwarding traffic because of STP. Now, there are few terminology that you might know, might should know before starting with STP. First is root bridge. So root bridge is the most important switch in L2 topology. All ports are in a forwarding state. So for root bridge is a device that is being elected as a root bridge, which is very important because it is the main where all the ports are in a forwarding state, and it is the main for the STP as well. Then there is BPDUs, which is also called as Bridge Port Protocol Data Unit. It is used strictly for detecting STP topology so that like switches can identify the root bridge, root ports, designated ports, blocking ports, etc. So it will have all the information when we like root bridge or any other switches is forwarding those BPDUs. It will add their own MAC address tables data to its own, and it will send it. So the BPDUs have all the information that is used to detect the STP topology. Now the third is root path cost. So root path cost is a combination of the cost for a specific path towards the root switch. So it's kind of a path from where you are to the root bridge, and it's the cost of that path. And the fourth is root bridge identifier. So it's a combination of root bridge system MAC. So it will tell system MAC ID, MAC address, system ID extension, and system priority of the root bridge. So based on system priority, you decide which one is the root bridge election, root bridge election. Then there is local bridge identifier. So it's a combination of the advertising switch bridge system MAC, system ID extension, and system priority of the root bridge. So it's a local bridge identifier. Then there is max age. Max age is just the timer that controls the maximum length of time that passes before a bridge port saves its BPDU information. So it will like count the time, like the length of the time before it passes through a bridge port, and it saves the BPDU information finally from coming to all of the switches. Then there is hello timer. So time that a BPDU is advertised out of a port. So like it starts from like root bridge, and it sends the BPDU and it goes through all the, that is the hello timer. And the last is forward delay. So, forward delay is the amount of time that a port stays in a listening and learning state. That is all forward delay. Now, this is mostly what spanning tree protocol is. Now, we'll talk about RSTP. RSTP is a concept which is also called Rapid Spanning Tree Protocol, which is a combination of concepts based of PVST and PVST plus and other enhancement incorporated to form the IEEE 802.1 W specification. And it is, as the name suggests, rapid, or it provides a rapid or more faster convergence of the spanning tree protocol. So in this one, there are actually four ports: designated port, root port, alternate port, and then backup port. So designated port, root port, alternate port, backup port. So for alternate port, it says that alternative connectivity to root port via a different switch. So it is not a direct port that is directly connected to the root, but if we go through like multiple switches in between, you will eventually be connected to the root bridge. So that is the alternate ports. And the backup ports are link redundancy towards the current root switch. So there can be multiple backups, and based on that, it can be said that it's a backup port. So it cannot guarantee the connectivity to the root bridge in the event of upstream fails, switch fails. So if the switch fails, it cannot guarantee that the connectivity to the root bridge is still there, and switches actually exchanges handshakes with each other to transition through the following many STP states. So for RSTP, there is three states. One is discarding, second is learning, and third is forwarding. So unlike the STP ports where there were 6 states, it only has 3, which is discarding, learning, and forwarding. So for discarding, you can say that the disable, blocking, and listening. So 1, 2, and 3. These three are the discarding state of RSTP. So it incorporates all 3 states. Then there is learning state. Learning state switch port can now modify the MAC address table as it is in the previous one with any traffic that is required. It does not forward any BPDUs. And the last one is forwarding. This is the same, that it can forward any BPDUs as well as the all network type of networks. Now let's talk about how root bridge election happens. So this video is now going ahead with a bigger one, so I'll just continue in the next video.